Okay, good afternoon, AP Physics. Like I said, I wanted to give you guys a preview of what we're going to talk about tomorrow. Hopefully those ramp problems are going well. So we're going to start talking about what's called horizontal projection. If you think about a projectile, this is just something that's flying through the air. Horizontal means that it's sideways. And so before we get to that, let's look at a simple case. A ball is dropped from rest at the top of a 30-meter high cliff. So we've got this cliff. 30 meters tall, and our initial velocity is 0 meters per second. Okay? The question asks, how long will it take the ball to hit the ground? Start with the kinematics list. So let's go YO, YF, PO, VF, AT. I'm going to go ahead and put Y on all of these so that I know I'm talking about the vertical direction. Okay? So I start at 30 meters, I end at 0 meters, my initial velocity is 0 meters, I don't know my final velocity, and my acceleration, because I'm falling straight down, is negative 9.8 meters per second squared. I put that negative on there because it's moving down. In this case, I'm calling down negative and up positive. So I need an equation that allows me to solve for t, but doesn't involve final velocity. That's going to be equation 2. Okay, so final is 0, initial is 30, 0, negative 9.8 t squared. So I'm going to do some quick math here. Negative 4.9 t squared. I'll pretend that I use 10 here, so this is 5. So t squared is 6. And t works out to be, give me a second while I plug it into the calculator, 2.45 seconds. So it takes about 2.5 seconds. Hold on, I'm making a video. Okay. About 2.5 seconds to hit the ground. Yeah. Another ball has a constant horizontal velocity of 15 meters per second. How far will it travel in 2.45 seconds? So in this case, now we're moving horizontally. So I'm going to go XO, XF, VOX, VFX, AX, and T. Okay. It doesn't tell me where I start, but since we're going horizontally, I can just call the beginning of the number line 0. I want to know the final. My horizontal velocity is 15 meters per second, and because it's constant, if I start at 15, I'm going to end at 15. I also know my acceleration is 0, and the time is given as 2.45 seconds. Notice, this time and this time are the same. That'll be important. Okay? So if I want to solve for x final and I know something about time, I can again use equation 2. Okay. Plug in everything. We've got a 0 here. 15 times 2.45 plus 1/2 times 0 times 2.45 squared. All of that is 0. This is 0. So my final position is just 15 times 2.45. Or if I plug that into the calculator, it's about 22.5 about meters. Okay. So now I know it's taken this long to hit the ground, and it's going to travel this far to the right. Okay. So that's going to be the first way we think about this. We also are going to think about it in terms of motion graphs. Okay? So the values in the table represent the vertical and horizontal components of motion for one single ball thrown horizontally from the top of a 60-meter cliff. So we have to imagine we have this cliff, I have a ball, and I throw it like this. That's how it's moving. Okay? We can represent the motion of the ball on the axes below. We're going to add a point on the graph for each time. The y value is the vertical height of the ball, and the x value is the horizontal position. Okay? So notice this is a position graph, not a position time graph. So when our ball is at a height of 60, its horizontal position is 0. At 59, it's 5. So at 59, it's at 5. At 55, it's at 10. At 49, it's at 15. At 40, it's at 20. At 29, it's at 25. At 16, it's at 30. And at a position of 35, it hits the ground. And so sure enough, if we map how this position graph looks, we get this right here. So what we're going to look at tomorrow is we're going to look at some more cases of objects that are flung through the air horizontally, and we will use that to ultimately build up vectographs and to hopefully get into angular velocity. Okay? Hope this video helps. I will see you guys in class tomorrow.